All right. So we're going to start off with some basic relay configuration here. So we have a 4-channel relay, which is kind of nice. 4-channel relay is essentially controlling 4 separate circuits. From the perspective of smaller one channel, you can do, or one circuit, you can do something like this, which comes in handy for a single circuit. If you have the multi, one of the nice things about using a multi-circuit is this concept of being able to power once and turn on a bunch of relays. So if you look at the schematic for essentially the labels here, we have a ground and a VCC, which essentially are our voltage so coming in. So we'll do like 5 volts. And then we have in 1 through 4, which will turn on each of the individual relays. If you were to do this from an individual relay perspective, you'd have to power each of these with your 5 volts and ground, as well as your connectors. So this is kind of makes it a little bit simpler here. And I've set up some of the wiring here just to kind of get us started. And I'll talk about this real quick. But essentially, we have a board here, and this is very basic, right? So from our perspective, this is just going to control the relays, so positive and then ground. And you can see they go to their individual areas. I've used red just for positive. Normally, I would use black here, but in our case, we're just going to use the orange and the yellow. It should be fine. From the relay perspective, connecting this is fairly simple. So if we wanted to connect this to the relay to start kind of giving power before we even tell the Arduino to control it, what we will do is we will take our ground wire, we'll plug that right into ground. So that goes onto that pin right there. So if you see it, ground. And then our red pin here, which is our power, will go into this VCC. So it's essentially power coming in to control the board. So we have 4 other pins left, and each of those pins control an individual relay. Now, you don't have to hook up every single one of these. So if you only have 2 circuits or 3 circuits, we can do that. You can do that way. In our case, we only have 3, so we're going to hook up the first 3. And we have our board right here. So we have an Arduino Uno Q. And in this Arduino Uno Q, we have our essentially female to female wires, because it'll go on female to male wires. That was my bad. And we have those in our digital slots. So if we take a look just a little bit closer here, you can see, hopefully if that focuses, you can see 2, 3, 4 are going to be our in cables, which is where we'll control the relays. And then we'll output to an individual board. So the goal of these relays, just to kind of give us something very simple, is to power these boards. So I have a maker, I have another maker Wi-Fi here. So if you see this, and then I have this Arduino Uno R3, so very basic. We're going to use both breadboards, and I'll explain why once we get to that point. But to kind of get us started, what we're going to do is we're going to plug each of these wires into the relay here. So, boom. So what we're going to do, and I'll show you once we connect these. So we're going to go 2 into 1. And I like to face these wires the same way. So we're going to do, and these are jumper wires, right? So in reality, when you're doing actual work, you'll probably use something a little bit better than jumper wires. So we'll do this into our 3 slot. And we do this into our 4 slot. So now that we've got this, and I'll show you where we have 1 pin missing, we can absolutely use that pin if we wanted to turn on the other relay. But in our case, we're just hooking all of these up to the N1 through 3, and then we're hooking these up to the board in 2 through 4. So we could make it easy and make it 1 through 4. I just, for the sake of this, I just wanted to build it that way. So what we'll do here is set up this incoming connection. So we want to power our board. So what we're going to do here, we actually, I think we can do, okay, we're going to do this slightly different. So instead of doing 2 separate boards, I've changed my mind. So the Arduino actually comes with a fantastic setup for this. So we have the ground wire. So we'll do ground. And we have something called 5 volt. So if we plug this in, you'll see that will be able to power the board. So we're using the 5 volts from the Q to power the relays. And then from these, we can actually use a higher voltage to power the other boards. So in our case, we'll use around 7 volts. I have a Matrix MPS 300 or 3005H, which is 30 volts. It's like 300 watts or something. But essentially, we'll wire these in here. So in our case, what we want to do for these is we want to use something called female to female, which will allow us to plug in the individual pieces here and then also on the board. So it'll go female in here and then female on the board. So what we'll do is we'll take some existing female to female. We will go from our common, which should be our center. It's usually the center. Now, the idea is, I think that these symbols, and I'm not as good at the electric as some other people, but we'll just screw that in. So this will be our common, so incoming, and then we have our outgoing to the actual board here. And then they'll have a ground to the board. And we'll show you how the ground works here. But essentially, what we're going to do is this is just your positive. So this will be your common positive, which is kind of a weird term. And this will be common going to, or this will be always open going to your circuit. So what we want to do here is actually interesting. So we're going to kind of we're going to use this board. We're going to negate some of the cool stuff that the board can do by using power rails. And we're going to go directly to one of the lines. So in our case, we're going to plug this into, we'll plug this into row 3. And this will allow us to use this row 3 as the power source. Then we can go out from that to our board. So in our case, we can do this. And we can go out to the board. So we'll plug that on the same line. So row 3 on that same side. And this is essentially how those power rails work. They just power the rows. So we're simulating that here. And what we'll do from here is we're going to go, so this is going to go from here. This will go to the board. So we're going to go here. We're going to go to the board. And one of the things that I don't like to do before I do the power, actually, I changed my mind slightly, is I like to do all the grounds first. So we're going to just do all the grounds. So in our case, and we can go straight into the power rail for the grounds. It's not a big deal. Just to keep it nice and simple. And we have a ground. So we're going to do this as well. And then we have another female to female. And we're going to do some ground with that as well. So great. So we're going to do this as well with our Uno. So we're going to go ground, ground. And then right here, we're going to go to negative. We're going to go to negative. And we're going to go to negative. Awesome. And actually, if you wanted to just like kind of make it on the rails so that you have a little more room, you could absolutely do that. So I'll show you how that's done here in a second. But essentially what we'll do is we're going to go, and you can do straight into the power rail. It really doesn't matter in this case. But essentially we're doing a jumper from our negative to that row so that we have our ground into each of the Arduinos here. And then we're going to go ahead and do our positive to our Arduinos. So we're going to go, this is going to be voltage in. So it's going to be VIN. And then for the first one, and now that we have that first one kind of set up, I want to show you kind of how this works. So what we want to do essentially, now that we have our 5 volts in, our ground is in our ground. So this right here should do some magic. The other one lights up, so it's a little bit different from the single. But we have this set up hopefully correctly. So what we want to do is we'll use 2 more female to female, and then we're going to do and I'm just going to use this jumper here. I'm going to move these positive rails down slightly. And we're going to turn this into this. And then what we're going to do is we're going to go positive here, and we're going to do that. And what we want to do first actually is plug our negative in. So I have these wonderful alligator clips that are coming from the matrix. So we're just going to plug that in. And I'm going to use a white wire for this because I prefer just to do that. So we have this going in. So we have our negative going to our negative and our positive going to our positive. And for the sake of the board, I'm just going to pull these a little bit closer to the actual power source. So that way we don't overstretch those wires. So now that we have that all situated, this should go to the board. The one other thing that we need to do is just put either another jumper or one of these, either the one of the cables that we used or just a small jumper. For our case, we're just going to use this wonderful small little jumper here. And we're going to go straight to our positive rail. And nope, not to negative. That would be bad. So a little bit of a stretch here. That's okay. And then actually, I might use the red because they're slightly larger. And in our case, that might be a little bit nicer. So we're going to do this here. Then we're going to go to red. So now we've just put in our jumper. So all of our positives here, in our case, are going out to the board. So where is it been? And then we can go, this one doesn't actually need to be here yet, but we can do that shortly. All right, so from the perspective of the wiring, we have our negatives here, which is our ground. We have our negative and positive. Negative is going to the negative rail. Positive is going to the positive rail. And just for the sake of trying to get this kind of situated, let's turn on the voltage. We'll do 7 voltage here. And then we will turn this on. And hopefully I don't blow it up. Good. All right, so now that we have our 5 volt going out, let me just make sure 5 volt is out to the VCC. Our ground is here. Great. And then this is here. Okay, so let's go back to our laptop. So we have a few things going on here. Let me open up Arduino's IDE and let me see if I can connect to the Uno Q. And I think I actually have to set the board to the Uno Q. Cool. So what we'll do, just for the sake of showing you how this works, so we have our pin mode. This is an existing setup here. Essentially, this was to control that single relay at port 8. We can define some ports here if we wanted to. So we can do int, and then we'll do, what is this? Which maker is this? I think this is the maker Vidor. So we'll just say mkor Vidor equals, and I think this is on, let me just make sure. And this is K4 and 2. And then what we'll do is we will take this, we'll make our Vidor, and then we'll mark that as high, and then we'll do a delay. We don't need the delay here just because we're turning it on high, but let's see if that actually works. Compiling sketch. Cool. So that did work. It turned it on and then it turned it off. So in our case, it looks like it's setting it automatically to that's there. So let me try that again. So MKV, and let me take that delay out. Try that again. It did turn on the board, so it turned on the Vidor, and then it turns it off. Awesome. So why does that happen? Oh, so it may. Let me try doing this as a low. So I may have reversed. If you do normally closed and normally open, you reverse them, that could happen. Okay. So if we were to take a look, now that we've kind of set this, I'll just show you exactly how this is working because this is doing exactly what we want it to. So here is the Vidor. You can see that the light is on the Vidor. Now, if we were to set this to, if we did this with a delay, so if I add, we'll just do a delay of 5 seconds, right? Five, so times 1,000. And we'll close this. Now, this is normally open. So we set that to low, which essentially just turns that on. So I had, now that I know how that works, I can actually set the pins correctly. So now that we do this, I can do digital right. And I'll show you this code here in a second, MKR by door. And then we'll go ahead and change that to high, which is essentially reversing it saying turn off. So 5 times 1,000, and we'll just show you this right here. And if we take a look at this, it's going to go ahead and turn on, and then in about 5 seconds, it should turn itself off. So we'll give it around 5 seconds. So I think I did 5,000. So we digital right MKR by door. So this is turning on. So let me see here. Let me just try to do 5,000. Let me do it for a slower, or sorry, a quicker turnaround. So this will turn off real quick. You'll see it. Ba-doom. And then delay. So should I do high and then low? We can do that. The one other thing that we probably want to do real quick, I'm just going to turn this off because I want to switch out these wires here. So I did this a little bit reversed. Oh, sorry about that. I did it a little bit reversed, so it's a little bit weird. So I did a normally open, which is not great. So I'm just going to do that reverse real quick. So what we'll probably want to do too is I'm just going to pull this. So I wanted to pull that just so that we don't have electricity flowing to that. And then I'm just going to take this wire here and I'm going to reverse that. So I'm going to do it here and it should be normally closed. So if we do nothing, or sorry, normally open. So if we do nothing, and if I did this correctly, which should be, we'll see here. We'll plug this back in. We'll pop this back on at 7 volts. And we will do this. So we're going to do this at a, so it's not on now, which is great. So what we want to do is do a digital high right here. So we'll go a little bit back to the laptop. I'll just show you what's going on here. So I changed that to go high. And now if you see here, one of the nice things about this is this board is now turned on. So I went ahead and fixed that. I did, it's normally open now instead of normally closed. So it's not on by default. I turn it on. You can do this if you do high, and now if we do delay, so we'll go back to the laptop and just show you real quick. So we'll do delay, 500, or we'll do 5,000 because it's milliseconds, and then we'll do digital right, and then we'll do MKR by door, and then we'll do low, right? So we're going to turn that off. So we'll do that. And now you can see this turns off. It's going to turn on. We'll do that right here. So we just show you that. And then the reason you don't see it going off, it is going off and on, is because we need another delay. So we'll do a 5-second delay after we do a low. So that was one of the things just to keep in mind. If you don't have, I didn't spell delay right. If you don't have a delay after, it will go through and loop again, and it will just turn itself back onto high. So now if we go back here, it's going to go 1, 2, 3, 4, 5, turn off, right? And if we go back to the laptop, just here, you can see we're just doing a delay after the low. So we're turning that on and off. So very, very simple. So what we can do now that we have this, I'm just going to keep this as, as a high. Boom. And we're going to do another setup. So what I'm going to do is I'm just going to turn off the power here because I don't want to get into a situation where I electrocute myself for whatever reason. Shouldn't happen, but things have happened before. So what we can do here now is, okay, so this is going to 5 volt. I just want to keep this over here. We're going to go do that female to female, but we're going to do the same thing on relay 2. So we're going to go here to relay 2. We're going to go ahead and plug this in, and I have some dog hair on my thing. I have a Great Pyrenees, so she sheds a whole lot. So we're going to put this into that first normally closed, normally open. And then we're going to go do our other pin, which is another female to female. So we'll do this. Boo, boo, boo. And we will do out to that other one. So this is the center is generally always common. I haven't found any that are not common. Common just being like, this is the common wire. So what we'll do here is this one. Boom. And we will go ahead and plug this into this other one. So we're going to do VIN. So voltage in. And then we're going to go here and we're going to plug this into that positive. And you can see that we have our ground going to ground. So that's good as well. So this is I think this is the Maker Wi-Fi with the MKR connector. So if everything goes well, we should be able to plug this back in. And what we'll do, we're just going to go back to, and I'm going to turn this on real quick because nothing here will turn itself off. So what we'll do is we'll set up this new pin. We're going to call this the Maker Wi-Fi. Maker Wi-Fi equals, I think this is pin 3, but let me double check. So this is 2. So this is pin 3. It's the purple. Okay, equals 3. So what we can do, and this is pretty cool, right? So we're going to do 5 seconds, and then we're going to do digital right. We have to set pin mode. So pin mode, we're setting essentially it as an input or an output. An input would be like a sensor. So if you're trying to measure temperature or air quality, that's an input. An output is like, hey, I'm sending electricity out to something, whether that be an LED, a breadboard, whatever it is. So we're going to do MKR Wi-Fi, and then we're going to do this as an output. And of course, we need our semicolon. And now we can actually use that pin. So we're going to do MKR Wi-Fi, and that will be high, right? And the same thing would apply to the next one. So in our case, just to show you before we move on, so we've just turned this on. So after 5 seconds, it actually turns the board on here. So now both boards are on through the relay. So if we go back here, I'm just going to go to scene. Sorry for the inception setup here, but now we have both boards on because both relays have been turned on. So now doing the third one is just as simple, right? So now that we have our basics set up, we can go ahead to and we're just going to unplug real quick, and I'm going to turn the on and off for my DC power. We're going to go here. I'm going to go and we're going to go to relay 3. Bum, 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 bum. And we're going to go probably more. I untighten that more than I needed to, but we're going to go here to this magical spot. I'm going to turn this back in, and we're going to go to our positive here. So I'm going to put this in that same line. So all 3 are in that same line on the positive. All 3 also have a negative going back. So the positive will go to the relay. The negative doesn't go to the relay. So the negative will go the negative to the actual board itself, and then the relay will only be the positive. So in our case, like it goes negative to board to board to board. Then it goes for the positive to relay and then out to the board. So the relay is just controlling and completing that circuit. So pretty simple stuff going on here. So now that we've got this set up, so here is our third one here. We're going to go ahead, and there is one more wire. So I actually have a red wire here already. So we'll use that instead of pulling off another one. That way we don't make a huge mess. We go and we will go to that common in the center. We'll go out. And notice we're only using 3 of the relays. We can absolutely use 4. In our case, we're just boom. Now what will happen here is we're going to go into our Arduino Uno, and we're going to go voltage in. We're going to do some magic here. This is a little bit of a mess because we're doing 3 separate things here. In reality, when you're doing this in like real production applications, you're going to have cleaner wires, so it'll be nice and smooth. So we've got our ground and our voltage in on that one. We just have to go back to our laptop. We'll go ahead and set that up, and we'll do int Uno, and we'll just call it Uno for short. It's on pin 4. We'll set that pin mode here, and we'll do Uno, and that's going to be an output because remember we're sending a signal output, and then we'll go here. So what we'll do now is we'll do a delay, and we don't have to do this delay, but that's just to show you like how it's all turning on. And then we'll do digital right Uno high, right? So as we hit that point of that next 5 seconds, so first, when the board starts, the first board's going to turn on, which will be that first maker. 5 seconds will go by, the maker Wi-Fi will turn on, and then the Arduino Uno will turn on third. So if we go here, you can see, digital right. I actually typed that wrong. So we'll go back here. I'm going to go back to scene just to show you. We're going to push this out, and you'll see this turn on first. Hopefully, if everything restarts and does its thing. Oh, you know what I forgot to do? I forgot to plug in the 5 volts, so this is not powered yet. So, let's leave it at 5 volts. That's my bad. I forgot to power on the 5 volts to the actual system. So now if we just send that out again, cool, just turned itself on. You can see it's turning all of its pieces on. Oh, so it's turning on each of those individuals. So what we'll do is I'm just going to shut that off. So I didn't have power going out. So it'll turn the relay on and connect the circuits even if the power isn't on. So you'll see that happen here in a second. But if we wanted to, what we could do to start, just so we can see this going on. So I will actually I'll do this. We'll create a function. So we'll do void turn off relays. So we'll create a function for this. And then what we'll do from here is actually set all of these pins to low. So I'm going to go here. And instead of doing a delay, we're just going to get rid of those. And we're going to do all of these to low. And just to make sure everything is clean as it turns on, then we're going to do turn off. Oh, turn of relays. Geez Louise. And then we're going to do this. And it's void. So what that should do is it should run the function here, which is a void. It doesn't return anything, but it takes action. And then we'll do the turn on. You can actually, too, if you wanted to, is void delay relay. You could absolutely set up another function for this and then keep your loop clean. It's all about what your preference is. So we're going to do this, and then we'll do turn off relays, and then we'll do this. Remember, you need the semicolon, or else it will yell at you. And then we can do delay. We'll do delay, just so we know what this is. We'll do delay on relay. Okay. So in our case, what we want to do is this, and then the other thing that we're going to do is we're just going to delay here, right? So we're going to do delay 5,000, which is about 5 seconds, and then we're going to turn that on. So what we'll do is delay 5,000. We'll do 60,000. So we'll turn them on for 60 seconds. So what we'll do now, so what this does, just to kind of explain what's going on here, is it will first set every pin to low, just as our starting point. I forgot my semicolon. Then it will delay for 5 seconds, so it will wait. Then it turns the Vidor on, the Maker Wi-Fi on, and then the Uno on, and then delays for 60 seconds. And what that will do is it will wait for that loop before it turns it back off on that relay. So it'll go back and turn off, turn on. There's ways to track that too. So if you wanted to wait and then turn on and then don't turn back off in the loop, you could. But just to keep everything super, super clean, we're going to go ahead and do that. Did I forget? Oh, delay 6,000. 6,000. I forgot to semicolon. I'm talking about semicolons and then I just totally forget it. So you'll notice here. Awesome. So all of our boards are currently off. You'll see currently now we have on. So that was 5 seconds. It turns on. Now we have our other board turn on. And in a second, or in a few seconds, you'll also see our Uno turn on. So you've seen now how the relays work. Essentially, you're turning on power. We're turning them on individually. So we're using this digital write high from our digital pens. And then we're, we can do whatever we want from there. So this specific relay will work with 120 volt, 240 volt with 10 amps. So if you were to put this in some kind of extension cord, 4-gang setup, you could do that. If you wanted to put this in as a smart outlet, you could do that with that as well. I would not recommend trying this with heavy machinery. You're probably going to outdo the amp, So if you try to do something like, washers and dryers, that might be problematic. Just to kind of give you an understanding of how that works, you have this concept. So how many watts is a dryer? So a dryer is about 5,000 watt, 1,800 to 5,000. So in the worst case, we'll say 3,000, right? So divided by 125 gives you about 24 amps. So at 3,000 watts at 125 volts, you're doing 24 amps, which would exceed the 10 amp maximum on here, which would mean that it would fry the relay. You don't want to do that. If you wanted to do a 30 amp relay for Arduino, You absolutely could. There are things out there to support that. So I think just check the specifics here. This a lot of them are 10 amps. Here this is 10 amps and then 5 amps for 250. But like certain things, okay, does this go up to 30 amps? Let's see here. So one half 30, yeah, 30 amps, 240 volt AC. So this may solve your problem. Just make sure that your amps match what your draw is going to be. It's all dependent on the appliances it's connected to. So if you're connected to some lights in your office, you're going to be much better off with a 10 amp relay. If you are connecting to large appliances, you probably have to go to like 30 amp or more, depending on the large appliance. So uh, just make sure that you're correct. So you've seen today how we do that. It's pretty simple. Connecting relays. Essentially, you have your controls, you have your power, and then you have your positive side going in here, or your hot wire going in here, depending on if it's AC or DC. And then you have your ground wire going to the actual device itself. The ground wire never goes through the actual device, or sorry, the actual relay. It will always go directly to the device. It completes that circuit for you. Hopefully you enjoyed this.